All right, recording's back rolling. We're in the last few minutes of class. So when I do my own number examples, again, my numbers are different than your numbers, but got all the same questions here. All right, so first question on the right side is what distance does light travel from the wheel to the mirror and back? So from the wheel to the mirror and back. It's a two-way trip. Now, I told you the distance to the mirror in kilometers. So you have to double that because there and back, that's 2 times that, but also convert to meters, and that's times 1,000. Okay? So I have 3 kilometers. Here, I'm going to do my 3 kilometers times 2 because two-way trip times 1,000 meters per kilometer. 3 times 2 is 6. That's like, for me, that's 6,000 meters. Again, all our values are different, so you probably don't have 6,000 in that box, but I bet you have a number that's the same order of magnitude, right? Maybe you have 3,000 or 4,000 or 5,000 or 8,000 or 7,000, something. How much time would it take to get for the light to get there and back? Now, you guys know light travels crazy fast. Oh, like imagine if you're like making a phone call to someone who's a few kilometers away. Like, there's not a significant lag. You wouldn't even notice it in your own brain, right? If you ever see like a lag, like if there's like some television interview and there's a reporter over on the other side of the world, right? That lag is those signals are like bouncing off satellites and going around the world, and even then there's only maybe like a second lag, something like that, right? So we're talking about definitely less than a second here, right? A lot less than a second. You guys know distance equals speed times time, right? So I bet then that time is equal to distance divided by speed, right? Now, since you're solving this whole problem backwards of what he was doing, you're allowed to know what the speed is. You know what speed, okay, I gave you the speed of light, right? And you know the distance because that's the answer to the first box. So I'm going to take my 6,000 meters and divide by the speed of light. So open parenthesis, well, I'll just type this whole number in. 299792458, right? That's telling me, here, I'll write this 2 different ways. How about that? 0.0000020 seconds, okay? Or in scientific notation, I could call it 2.0 times 10 to the negative 5 seconds, right? So there's 2 different ways to express the same number. Okay? So yeah, again, my numbers are different than your numbers, but you should be getting a tiny time interval, something about like 10 to the negative 5 seconds. Okay? How far would the wheel turn from a gap to adjacent to, right? Now here's where the number of teeth matters, right? Because if I have 29 teeth on my own cogwheel, my cogwheel needs to turn just a little bit, like 1/58 of an entire revolution. Why 58? Because 29 times 2 is 58. There's 29 teeth and 29 gaps. A tooth needs to cover an adjacent gap. So this whole thing needs to turn just a little bit. So I'm going to take 1 full revolution, which is 2 pi radians. Isn't it 2 pi radians, 1 full revolution? And divide by 2 times the number of teeth. And I have 29 teeth, so I'll do 2 times 29 down here, right? And 2 times the number of teeth because there's an equal number of gaps to the number of teeth. So 2 pi divided by 2 times 29, or if you like, you just cancel the 2's on the top and the bottom. Okay. So I'm getting 0.108 radians. You guys should be getting something kind of similar to that. Okay? All right. Ooh, one method answering the question on the front, or I guess on the left side of this paper, right, involves just these answers here. And you can see, you can get a hint from the units. Guys, the units to the answer, how fast do we have to spin, is radians per second. Hey, here's how many radians it turns, and here's how many seconds. Hey, this many radians, this many seconds. Can I just take this many radians, divide by this many seconds, and get the answer? All right. Let me go ahead and do that, and then I'll come back and answer these last 3 and see if I get the same answer from a different point of view. So I'm going to take 0.108 radians divided by 2 times 10 to the negative 5 seconds. That's going to tell me, 2 times 10 to the negative 5. Okay, so all right, there you go. I'm looking at 5,400 radians per second. Now, when I look at my answer key, like this last digit might be some different number. It's like 5,504. I don't know. It's probably pretty close to 5,400 radians per second. Okay. All right. Let's continue over here. All right. What is the radius of the wheel? Well, I told you the diameter of the wheel in centimeters. Guys, how do you go from diameter to radius? Divide by 2. So I have 108 centimeters diameter. I'm going to divide that by 2 to turn that into how many centimeters is the radius. But then I want the answer in meters, which is a better way to work with it for your calculations anyway. Get everything in base SI units. So how do you go from centimeters to meters? Divide by a what? How many cents are in a dollar? 100. Divide by 100. So it's 0.54 meters. Right, I gave you the units on all these. Right? How far would a tooth or gap move during this process? Right. So this tooth moves a little bit. Right. Now that does depend on how large is your wheel. Right. So do you guys remember? Actually, that's what I broke out this poster for right here. Right. If you know how far the wheel has to turn in radians, and you know the size of the wheel, like the radial size, I can tell you how far you're moving, say in meters or centimeters out on the edge. And so let's take up. So x equals theta r. Okay. So I'm going to take 0.108 radians, that's my theta, and multiply by 0.54 meters radius. That's telling me 0.058 and change meters. Okay. I could also interpret that as like 5.8 centimeters, which I think makes sense too, right? Like during this whole process, the tooth would only move, maybe just a few centimeters. Right, that looks reasonable. I think maybe a few centimeters. Right, and then what's the linear speed of a tooth or gap? All right, so I could do, how about linear speed is distance divided by time, right? X divided by t, right? Meters per second, miles per hour, kind of. Let's take this many meters, divide by this many seconds. So take 0.05832 meters that tooth moves, divided by, open parenthesis, 2 times 10 to the negative 5 seconds. And that's telling me, woo, 2,900 and something meters per second. Right? So that's a crazy fast linear speed. Okay? Again, like if you were like a ladybug that landed on a tooth and just go on for the ride, you're moving that fast relative to the outside world. But the center of the wheel is not moving at all. Okay, so maybe I want to tie this all together by saying, like, what's the angular speed of the wheel? Right? Which was the main question on the left side of this page. And you guys know that angular speed could be linear speed divided by radius. So let me try it from this point of view. If I plug these values into this expression, do I still get 5,400 radians? Maybe like plus or minus a few radians. Let's see if I do. So I'm going to take my linear speed of 2916 meters per second, divide by the radial size of 0.54 meters. All right, moment of truth. Is my calculator screen going to tell me 5,400? Hey, 5,400, 5,400. That's radians per second. And yeah, I verified the answer. Yeah. So hopefully you get numbers pretty close to those. If you think you got all your own values correct, then you can throw that in the grade tray. Guys, don't forget that you have also all the questions on the front side of this paper answered, all the algebra-based questions, right, that we've gone over the last couple of days. Right? So if you've completed this entire page, if you have not completed the entire page yet, you want a few more days to work on that or check your answers, then it's okay if you turn that in on Monday. All right, let's wrap on that recording.